Hey, what's up, Ziguanas? This is day 15 of the 30 days of Zig Coding Challenge. Join me as I apply over 2 decades of programming, professional programming experience, and around 15 years of code teaching experience to master this beautiful new language. My name is Dusan. Welcome to Zignited. Yeah, so almost halfway through the 30 days of Zig Challenge. After this stream, it will be exactly a half. So let's just jump straight into it. And today I would like to go through errors and their handling in Zig. So let's see what they say about errors. Error set type. Error set is like an enum. Okay. However, so they say error set type, not only error. So is it always set, or we'll see. However, each error name across the entire compilation gets assigned an unsigned integer greater than 0. Okay, the error code. You are allowed to declare the same error name more than once, and if you do, it gets assigned the same integer value. Okay. The error set type defaults to a unsigned integer with 16 bits. Though, if the maximum number of distinct error values is provided via this flag, error limit, num, and then the number following, okay, command line parameter, an integer type with the minimum number of bits required to represent all of the error values will be used. This is the minimum number of bits required. Okay. Got it. You can coerce an error from a subset to a superset. Okay, let's see what they do here. And let's copy paste things. First, see what they do. They do something here. They define these 3 errors, and they say it's like an enum, so they'll get user codes, and then they create an instance of it out of memory, and then let's copy paste this entire thing, and let's see how it will behave. This is from yesterday. Let me delete all of it, and let's put this part here, and let's see. Again, constant, which is an error type. Then they define this one. They are actually using 2 different constants. So for a second I thought that they are kind of like reusing this one here, but they are just using the same one 2 times. 2 different constants. Okay. Let's see what they do next. Core set to superset. Okay, because this is like a superset, has more errors defined, so they'll probably coerce. And how they do it, so they call this function here, which receives one parameter. They call it err, and this is the type allocation error, which is this one, so the subset, right? And it returns file open error, which is, I guess, yeah, this one's superset, and they just return it. So it's just like a pass-through. Okay. And then when they call, not test, if it's possible not to test. I'm not sure how these errors work yet, so I would actually want to do this down there. So let's actually, yeah, I will just copy, and then if it doesn't work, I will revert. I want to do it here. So generate the constant, and they want to see what it is, and I will do that in this way. Yeah, out of memory. That's what they expected. By the way, sorry if I'm slower today because I slept like literally 1.5 hours last night. I couldn't sleep for some reason. So that's why I would try to do my best to focus as much as possible. So this is the expected file open error out of memory. It's a bit different. It's error.out of memory. And they say here file open error.out of memory because they define it here as an error. And this is what we get the runtime, but I haven't tested if they're equal. So let's actually print equality and see if this is equal to the other type they are expecting here. So basically this. And I can same. Yeah, it's true. So they are equal. I guess the part inside is what matters, not the wrapper or how it works. Okay, let's see the next section. But you cannot coerce an error from a super. The opposite doesn't work, and it will cause an error. So this is the same. They just changed this one here, and then yeah, just change. Okay, so let's change this function here, and I will comment out the original one. And let's see how this will break. Yeah, I have to pass a different one here. Yeah, this is my mistake. So I got a different error. Where is it here? Oh, yeah, this is the one. Actually, let's copy this entire thing. I want to have it for now at least. So now I guess I will get the same error that they get, maybe a different one because they are testing it. Clash of local. Okay. My bad. Now let's get their error finally, if possible. Okay, error out of memory. Found error, yeah. So they're expecting one and found the other one. Yeah, it's the same error. Okay. What they did here, they just like used the catch. So this is the part, I believe, try catch error handling. But they did not explain there is something different than in other languages. Let's see if they will. There is a shortcut for declaring an error set with only one value. So they're focusing on this, how do you declare it, not how to actually try and catch. By the way, if I say, hey, good evening, Robert, how are you? So by the way, if I say except instead of catch, sometimes it's because I do a lot of Python these days, so that's why. But I mean catch if I say except by accident. So let's say what they do. There's a shortcut for declaring an error set with only one value and then getting that value equivalent to, okay, let's do this, and now then let's comment out these few lines. See what they want to do. 1, 2, single. Okay, so this copy, not copycat, and do this. So this one is equal to, this is what I actually, something similar I just said a few minutes ago. So error.file not found is equal to this dot file not found, which is basically this equals to this, at least in this case. So as a shortcut, okay. So if you have an error set with only one value, you don't have to do the full thing. Okay. This becomes useful when using inferred error sets. So I guess we'll look them later. The global error set. Any error refers to the global error set. Global, I guess the built-in one. They want to say that one, or maybe something else. We'll see. This is the error set that they're literally going to explain now. This is the error set that contains all errors in the entire compilation unit. It is the union of all other error sets. Okay. You can coerce any error set to the global one. So this is basically something similar to what they said here, that you can coerce the subset into a superset. And because this one contains all of them, it's kind of the same, if not exactly the same. Okay, you can coerce any error set to the global one, and you can explicitly cast an error of the global error set to a non-global one. So explicitly cast. This inserts a language level assert to make sure, language level assert, okay. To make sure the error value is in fact in the destination error set. Okay, makes sense. The global error set should generally be avoided because it prevents the compiler from knowing what errors are possible. Yeah, because it takes them all and it cannot know. Knowing the error set at compile time is better for generated documentation and helpful error messages, such as for getting a possible error value in a switch. Okay. Yeah, easier to make docs. Okay. Automated. Error union type. An error set type and normal type can be combined with the binary operator. So this is, I believe, not. If they're not doing something weird, should be not. Binary operator to form an error union type. You are likely to use an error union type more often than an error set type by itself. Okay. So basically, you take the set, you use this operator, and then you create a union. Let's see the example. Function to parse a string into 64-bit integer. Okay, so this is, I believe, all here. It's connected, so I will copy it once, and I take this one and import. And let's delete. I don't need to save it. And also let's delete here. I'll just leave one print that I can easily copy paste. This one is a big one. Okay. And I'll make this side of main. And then I'll look at it. Let's see what they do. Function parse u64. They create this parameter called buff, which is an array of constant u8s. Okay, then they create another one, radix, which is u8, and then they return a union, I guess. Right, that's what they said that this will do. Union type. Did I do unions? I forgot my mind. Just like I said before, I slept. Yeah, I did, of course. Enums and then unions. Yeah, okay. What the name of it? Yes, of course. Literally yesterday, right? No, I slept 1 hour and a half last night. 1 hour and a half last night. That's why my brain is a little bit foggy. Okay. This returns a union. of U64, then the first thing inside of the body, yeah, it's up to here, right? This is the end of the function. Okay, so the first thing is that they create a variable x, which is U64, set it to 0. Then they have this for loop. Let me just see in the general. Okay, after the for, they just return x. So obviously they will try to change it something. And will change it. So this is a for loop, for buff, and then this is capture group, right? So if understood correctly, this is kind of like an anonymous function in other languages. So it will take from this buffer, it will take element by element and input it here, basically, and it will iterate. So inside where this for, yeah, this is way down. And let's see what they do. They convert this to a digit. Then they literally call digit here. It's a constant. Then they ask if the digit is greater than or equal to whatever they receive, a number. Then they return value. Okay, they are invalid character. So they will just like set the limit. What is the highest number that they will allow? Then what they do next. So if this doesn't return, it means it's within the limits they want. Then another variable ov with overflow. Multiply with overflow x and the radix. So basically multiply the x by the radix, and that's 0 at the beginning. And the radix is whatever they send inside. Okay. And then they take the ov first element, not first element with index 1, and they ask if it's not 0. But why is this? Why when they multiply, what is the type here that they get? So they multiply U64 with U8, but then they kind of like take that as a point. Yeah, they say here pointer, x pointer equals radix. Okay. Okay. Then it's not really an anonymous function. That is too complicated. Think of it as pulling out a value from something. And for on slice, it retrieves current element. Okay. The switch on tagged union yesterday, it pulls value under the tag. Okay, thanks. Okay, let's see the next part here. They do something similar, but instead of the multiplication with overflow, they add the overflow OV0 and the digit, which is this one, which is what they got by converting C to a digit. Okay, and then again they test if OV1, the second element, not equal 0, return K. They kind of like want to see the overflow, I guess. Okay, with this square brackets 1. Okay. X equals OV0, and then they return it. Okay, and then let's see what else they do here. Character to digit. This is another function. Okay, let's see what they do. So they call it here. Yes, they did here. Okay. So I thought it's a built-in, but yeah, it doesn't have at. Not a built-in. I missed the part that it doesn't have at. So this one takes the character from there. I mean, it's a character here. It's U8, and they return a U8 as well, and they return a switch. So they switch C for all these values. So if it's basically a numeric character, they will return C minus whatever is the number of the 0 in the Unicode. So they'll basically get the number itself. Yeah, makes sense. So this will be, for example, I forgot what is the number of 0, but let's say something like random. Let's say 90. And then if you have 91 and minus 90, it will be 1. So it will be the corresponding one. Okay, the same thing here. C minus a plus 10. And here a to z, c minus lowercase a plus 10. I don't know why they do 10. Why not just like c minus a? Why they add 10? Aha, they want to start after. Yeah, okay. Like a hexadecimal number, basically. Like you want to start after 10. Okay. Else max int u8 and max int. Where is this function defined? It's not. It's imported here. Okay. So the maximum value of the u8 type, and then finally they test it. Result equals try parse. They put this number here, then they iterate here through it. So they take character by character, they convert to a numeric value of it, then they do these operations here, they test for the overflow and everything, and then they store that into a result, and then they want to results be basically the integer version of it. Okay, got it. So they're literally converting they created the code that will convert a string literal to numeric. That's what they say, right? This function parse string, yeah. So that's literally what they said. Okay, makes sense. Let's just like run it and see if this result matches this part here. Point found type info where was it the try? Then I have to chain it, I guess, with the expected, but I just want to test like this without try, just to see the result, and then go back. Yeah, okay. So yeah, basically they are returning here these errors under certain conditions if the integer is too large, so that it will cause the overflow. Then this will return the error flow. And before it was kind of similar. They're just like passing through the errors and converting them. Okay. And try, they don't explain this try except part. They do later. Okay. So let's click to see how far it is. Okay, it's not that far. I'll be patient. The next thing, notice the return type is exclamation mark U64. This means that the function either returns an unsigned 64-bit integer or an error. Okay. We left, let me just see that one more time. Where is the function? Here. Okay. This means it can potentially return error. Because they are creating a union, right? The error and the type U64. That's why. Okay, so it can be either an integer or an error. We left of the error set to the left of the exclamation marks, so the error set is inferred. Let me just see. I don't see any explicit error set. It has to be then automated completely. We left off. Okay, yeah, okay. Within the function definition, you can see some return statements that return an error. Yeah, I've seen them, but everything was fine. And at the bottom, a return statement that returns U64, both types correspond to any error. Okay. So basically, if you omit, it means any error. Right. What it looks like to use this function varies depending on what you're trying to do. One of the following. You want to provide a default value if it returned an error. If it returned an error that you want to return the same error, you know with complete certainty it will not return an error, so want to unconditionally unwrap it. You want to take a different action for each possible error. Okay. Catch. Okay, here we are. If you want to provide the default value, you can use the catch binary operator. And let's see their example. Okay, this is just like a dummy one to do 80 thing. They received the U8 array, right? Void is the return type. Then inside they create a constant where they parse. They use the same function here, yeah. str10 catch 13. They just added after. Wait, they already had it there. No, they did not such thing here. I probably saw it somewhere before and then I thought I saw it here as well, but not. So here they just add catch 13. Let's copy paste just to compare it side by side. It will be easier. Just to double check. And here I deleted the original. Oh no, it's the same. Okay, just the different name. So yeah, literally they just add catch and then the default value. Okay. And they just dump it here. In this code, number will be equal to the successfully parsed string or default value of 13. Makes sense. The type of the right hand side of the binary catch operator. It's a binary, so literally it cannot have anything here. It doesn't count. Just applies to 13, so it cannot have anything on the left. No, it's binary. Oh my god. So not unary, binary. Quite the opposite of what I said. Okay. If you... No, wait, I skipped one. The type of the right-hand side of the binary catch operator must match the unwrapped error union type or be of type no return. So this is a new type they haven't touched before. If you want to provide a default value with catch after performing some logic, you can combine catch with the name blocks. So like if I want to do something a bit more complex, then let's see how they do it. They receive a string array of U8s. Void is the return type again. Then the same thing like before, they just don't say catch 13, they say catch block, and then in the block they do the 13 thing. Let's run this one at least. So they do depend, so this one, they do depend on the previous code, so I will leave it. And let's just call it. So here. Wait. I want to say send in U8 array and then to see This one, yeah, this one will actually return void. So it basically doesn't matter. I don't have to store it anywhere because it's void. I actually don't need this in a function because it's void, so no point. I can just do it down there. Okay, const number parse u64. Let's comment out this part because I don't want to have multiple outputs. So only one number equals parse u64 str and 10. Then they catch blk and then do things here which I'm not going to do, and then they just break blk here. Okay, so if I just put this, no, they dump the number, is now initialized. If I don't dump it, if I do here, yeah, of course I didn't define the str, so I just need something. Let's do this one, but it has to be like this. Yeah. Okay, and if there is an error, so let's try to do something like this. It's still U64. Yeah, it's a huge one. Okay, so let's then send something that is not numeric. Let's say this. Yeah, and then it's 13. Okay, makes sense. Nice. So this was about catch right now. Try. Let's say you want to return the error if you got one. Otherwise, continue with the function logic. Then they provide the next example. So what is different? So they have this because they want to return an error. So that's why. So then it's this like any, how they call it, any error. So this is any error or void. The const number equals parse, the same thing, catch, and again, capture group. So they will catch it, and then they will just return it. So it's a pass through. Okay, let's test this one instead. And I don't need this previous version of it. And yeah, I have to return. So this, because I'm in a main, doesn't make sense. So let's do it in a function. Do they have? Yeah, they have the entire function. So let's do it here. And then I want to send a string calling this do that thing. So let's say number equals, and I will do it here. And let's do this one. I don't need this one anymore. Let's say I mismatched the type. So it expects the U8s. And what I sent the pointer, constant pointer. Yeah, so I didn't play with this. I forgot about these different pointers and how to convert them in a proper way. So how can I convert this part here, this thing here, into this? Okay, doesn't matter. Let's go to the next one, because this doesn't make sense that I test it inside the domain. I have to call a function, and I will not just like spend time trying to remember how to convert. This is something that I did like 10 days ago. I played with these types, like the arrays and slices and pointers, and I didn't practice them. So that's why I want to do it tomorrow on this, let's say, a bit more improved tic-tac-toe because of this, so that I refresh my memory. There is a shortcut for this, try expression, blah, blah. So, okay, so on here, they change it. Aha. So this previous example, they actually didn't even use try, right? Yeah. So they don't have any try. And then they just like here implemented try to basically do the same thing. Try evaluates an error union expression. If it is an error, it returns from the current function with the same error. Otherwise, the expression results in the unwrapped value. Cool, cool, cool. Maybe you know with complete certainty that an expression will never be an error. In this case, you can do this. Catch unreachable. So this if you're certain. Okay, makes sense. Here, here we know for sure that 1, 2, 3, 4 will parse successfully. So we put the unreachable value on the right hand side. Unreachable invokes safety checked illegal behavior. So in debug and release safe triggers a safety panic by default. Okay, so while we're debugging the application, if there was a surprise error here, the application would crash appropriately. Okay, you may want to take a different action for every situation. For that, we combine the if and switch expression. So what do they do here? So this is the beginning that is like before, right? But with if. And then they parse it. And then they check what they get if it's not void, because parse, I forgot how the parse it was all the way up here. I already forgot what it can return. Aha, U64 or an error. Okay. Then they have this capture group. They take that number from parsing the calling the parsing function. Then they do something with the number. So I think this is just like a dummy function, but they don't actually have a function with that name. Yeah, it's a dummy one. Okay, so they just do something else. Error, they take the error. So basically, this will be true if you don't have an error. If you have an error, it will be false. It will jump here to the else branch. Again, capture group, which will basically then use that error and switch it. And in this case, they just check if it's overflow, then they handle the overflow. Yeah, this is like quasi-coded, you cannot even run it meaningfully. We promise that invalid char. How you guys pronounce this? I always say char. In my mind, it's easier to say char than car. I know that some people pronounce it car, but in my mind, it's easier to say char because like ch. I know it stands for character, so it should be maybe car, but simply because of this char, char. Or crash in debug mode if it does. Okay. So this is why we say unreachable. We promise it won't happen. Basically, this is how you promise in Zig. Okay, this is how you swear in Zig. Finally, you may want to handle only some errors. For that, you can capture the unhandled errors in the else case. So only some errors, okay? In the else case, which now contain a narrow error set. So I will have to play definitely with this. So tomorrow I will refresh my memory about these types and pointers, like these two kinds of pointers and arrays and slices, and converting between them so that I can understand this better. Not to understand, but to use. In this case, I couldn't use because I didn't want to waste time on conversion. Sorry. So let's see what they do here in the else. So this is the same, but here in the else, they take leftover error. Okay, this is kind of like the most, in their case, it's kind of like the important one that they expect to be a common thing. But this is like something that is maybe not so usual. And then they just, like in this case, they just returning. So quasi code that doesn't do anything useful, but they can make a point at least. You must use the variable capture syntax. If you don't need the variable, you can capture with underscore and avoid the switch. So now this is replacing the switch. Let me just see here. So else error, else So they just like use the underscore to dump it, and then they don't have to switch. They just like react if there is an error. Basically, you do whatever for any error, right? Yeah. Need the variable. Okay. Errdefer. Oh, this is, I think, what I heard about. Like when the people spoke highly of Zig. This is something that the first thing that I heard is something about deferring the errors, and so I use defer in some other languages, and I love the idea. So that's why I think I have an idea what they will do. So probably not all the details, but I can guess how they will use this to kind of like force you, not force you, but allow you to, or maybe even force, I don't know, to just like specify whenever there is like a potential error that you kind of write the code that will deal with it, but that code executes later. So that's, I think, the point, at least in these other languages. Yeah, scope level defer is awesome for errors. Location freeze, scope level. So then I guess it will be like at the end of the scope, right? It will just like you write it here, something that is potentially dangerous, then immediately the next line you say something defer, and then it will not happen there. It will just like wait for the end of the scope, right? If I understood correctly. And let's take some water, by the way. Okay. So let's see what they say. The other component to our handling is defer statements. In addition to an unconditional defer, Zig has Errdefer. It has two of them, unconditional and the Errdefer, which evaluates the deferred expression on block exit path. If and only if the function returned with an error from the block. Okay, cool, yeah. Let's see the example. Create foo. I don't copy paste because they literally like they don't do anything. Maybe in this example they do, but in the previous few examples it was pretty much a skeleton. Let's see if this one is different. So again, any error and foo. What is the foo here? Like a type. I didn't see it before. Where they declare this and what it is. Const foo try to, or maybe it's quasi-code again. Const pseudocode, how they call it. Const foo equals try to allocate foo. And where is this try to allocate foo? Ah, okay, these are all dummy code. Okay, okay. So these are pseudocodes. I can just read through it. Now we have allocated foo. Okay. We need to free it if the function fails, but we won't return it if the function succeeds. So Errdefer, deallocate foo. Okay. Cool, cool. So you return it if it's fine. Otherwise you free it. Const temp buffer. Allocate temp buffer, or else return error out of memory. Or else. The MP buff is truly a temporary resource, and we for sure want to clean it up. Aha, so they kind of give the example, like imagine it's a temporary, and you want to clean it up before this block leaves the scope. So that's why you do defer. So basically, this is similar to this here. But in this case, they just use unconditional defer, but they have this or else part here. Okay, okay. So this is kind of like in combination, something that is similar to this part. So I will have to play to understand for sure. If param greater than 1337, this is this one. Return error invalid param, okay. And then return foo. So here they directly return the error. Here the Errdefer will not run. Yeah, since we're returning success from the function, but the defer will run. So this one will run and this one will not. Okay, because this one is unconditional. Okay. The neat thing about this is that you get robust error handling without verbosity. Yeah, I agree. And cognitive over, I mean, I just like understand the concept. I will have to play to see how the things work for sure. Cognitive overhead of trying to make sure every exit path is covered. The deallocation code is always directly following the allocation code. Yeah, this is what I heard even before. That's what I meant. The error defer statement can optionally capture the error. Let's see what they do. Capture the name of the function. Maybe this one actually runs and does something. Let's see. It takes the capture is the name of the parameter. I think this is, like they said, an optional, so I did not play with these. And it's a pointer to an option, right? So I kind of can understand what they mean here, but I will definitely have to. Yeah, because they are after here, after errors, they speak about options, so that's why I'm not familiar with it. But let's just like take a look anyways. Errdefer, capture group, take the error, and then they assign it to the captured. Aha, that's what they said, like you can capture the error, the Errdefer. So this is what they meant. You take this pointer to any error, and then you just like catch and attach the error to it, and then you return general failure. Okay, then they test it. They say captured is, I guess, optional, any error equals null. If capture error reference to captured address of, right? That's how they call this operator, address of captured. So if there's something there, if it's not null, then oh, this is so then unreachable can have multiple things behind, not only one simple thing. So unreachable else. This is so weird, but I kind of like feel I'm going to love it once I get used to it. So unreachable else capture group error, then they try two different things. They try to expect the equal. So okay, this testing thing doesn't matter, but they just like want to see if general failure is equal to the capture option or to the error. And it passes, so I guess it's equal to both. A couple of other tidbits about error handling. These primitives give enough expressiveness that it is completely practical to have failing to check for an error be a compile error. If you really want to ignore the error, you can add catch unreachable and get the added benefit of crashing in debug and release safe modes. If your assumption was wrong. Okay. Since Zig understands error types, it can pre-weight branches in favor of errors not occurring. Pre-weight branches. Okay. Just a small optimization benefit that is not available in other languages. Yeah, this looks very interesting. So far I've seen it's a very optimized. I mean, it makes sense because it's low level like C. I mean, when I say low level, I have some guys that are fighting me. They say like it's not low level, like assembly is low level. Well, yes, it's low level, but if you compare Zig with Java, it's definitely lower, or Zig with, I don't know, Go and Python. So that's what I meant when I said low level. So it is meant to do these kind of things that are close to the machine. So that's why it makes sense that they optimize, but they do a very good job. So I've never seen like what they say literally, like I've never seen not only this, but the other things also, like switching the type, what I did yesterday. So if you say U2 and then switch it, and if you cover 0, 1, 2, 3, you exhausted all the values, and it will optimize the code under the hood for the machine, so that you don't have to waste larger types and things like this, these details. I like it. I like them. See also differ. Okay, an error union is created with exclamation binary operator. So this is the negate in binary, but obviously here they're using it in a different way. You can use compile time reflection to access the child type of an error union. Okay, let's see example. Who is any error, or it can be I32. So this is the union, and they set it to undefined. Yeah, this is very confusing. Why they set it to undefined? Why they don't select any of these two types? Coerce from child type of an error union. Foo 1, 2, 3, 4. Coerce from an error set. Okay, so this basically means because it's part here of the union I32, and this is I mean, it's comp time int is the literal, but it can fit into I32. Then from the error set, they take the error set, which is any error. Now this is coming because of this. Then use compile time reflection. Yeah, this is the interesting thing that I wanted to see. To access the payload type of an error union. So expect, okay, a lot of nested things. Let's see first from here. Error union, payload. Aha, there is this like field or whatever it is inside. It contains something, probably a struct or something like that. That contains payload, and they test if it's I32, and they are expecting it for the payload. Okay, so they are basically putting a dot. Let me just like not miscalculate the number of parentheses. So here, so this is type info dot error, and the type info is type of foo. So they take the type of foo, then they pass it to the type info, and then they will get this struct that is type info. Then they go inside error union on that type info result, whatever it is, then payload, and they compare to with I32. And in this other case, it's the same thing, but they just don't get the payload. They at the end go to the different path, to the error set. So payload and error set. Reread one more time. An error union is created with blah blah. You can use compile time reflection to access the child type of an error union. Okay. Okay. Payload and error set. Margin error sets. I mean, I want to say, okay, I kind of like get it, but I will have to play a lot with this to fully understand. I just like get the general idea. Use the two pipes operate, so basically like the binary OR, bitwise OR, to merge two error sets together. The result error set contains the errors plural of both error sets. Okay, documents from the left hand side or right, documents from the documents. Okay, I will not play with documents. I mean, not that they are not important, but I just want to focus on more important things. Error sets, then its functions in Zig return a possible error. Zig supports inferring the error set to infer. So yeah, this because today is kind of like more of me reading the docs, a bit more abstract because these are a bit abstract things. Of course, they are all applicable, so they are also practical, but simply like the way they explain is a bit abstract because many functions in the return possible errors support inferring the error set. To infer the error set for a function, prepend the exclamation mark operator to the function's return type, like okay, add inferred. They receive comp time variable parameter of type t. Then they have the type here. Yeah, this is too advanced for me now. I'm not following. I will have to slow down dramatically to understand all these things. So just move on. Next here. Let's see actually first here if it's the similar thing. Maybe I can skip all these. Returns trace. So let's see what they say. Function has an inferred error. So this is about the before in this situation. Okay, this limitation. Okay. A return traces. A return traces show all the points in the code that an error was returned to the calling function. This makes it practical to try else everywhere and then still be able to know what happened if an error ends up bubbling all the way out. Okay, yeah, nested, and then so they have one function with try. They have another one with two tries. And here in this one they call foo. In this one they call bar and bang. So this is bar. There are two bangs. Bang 2 was the one that they call. And they try even in a bar. It has its own try, and then Even in the else, it has another try. Try bang 2. So all the paths lead to bang 2. So then this can like bubble back to wherever it came from, either here and then out or directly here and then out. Okay, understood. And you get the error stack here. Okay, look closer at this example. This is no stack trace. Yeah, this is return trace. Okay. This is no stack trace. You can see that the final error bubble was permission denied. Let's see. Where is the final top? Or yeah, at the top. Okay. But the original error has started. This whole thing was file not found. So where was, yeah, this one is the last one. Yeah, this is the last one that they showed. Then it's first one. So chain reaction, bubbling. The code handles the original error code and then returns another one from switch statement. Error returns traces make this clear, whereas a stack trace would look like this. Let's see what's different. So permission denied at the beginning, and then so here you just see in which line it broke, but you don't see the original error. Okay, so that's why switch. But it's more informative. Here the stack trace does not explain how the control flow in bar got to the hello. Yeah, it does not. To the hello call, one would have to open a debugger or further instrument the application in order to find it. The error return trace, on the other hand, shows exactly how the error bubbled up. This debugging feature makes it easier to iterate quickly on code that robustly handles all error conditions. This means that Zig developers will naturally find themselves writing correct, robust code in order to increase their development pace. Error return traces are enabled by default in debug and release safe builds, and disabled by default in release fast and release small. Yeah, so many different modes. I'll have to read eventually about them. There are a few ways to activate this error returning tracing feature. Return an error from main. An error makes its way to catch unreachable, and you have not written the default panic handler. Okay, then it will panic. Use error return trace to access the current return trace. You can use std-debug dump stack trace to print it. This function returns comp time known null when building without error return tracing support. Okay. Analyze performance cost. There are two cases: when no errors are returned, when returning errors. For the case no errors are returned, how many? How? Okay, optionals there. It's close. Okay, so many things about errors. An error mixed with to catch a river. You can blah, 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 okay. Here. When no errors are returned, when returning errors. For the case when no errors are returned, the cost is a single memory write operation when no errors are returned. Okay, only in the first non-failable function in the call graph that calls a failable function. As if when a function returning void calls function returning error, this is to initialize this struct in the stack memory. Struct index use size, instruction addresses and size. Okay. Here n is the maximum function call depth as determined by the call graph analysis. Recursion is ignored. Accounts for 2. Pointer to stack trace is passed as a secret parameter to every function. Pointer to stack trace, okay, as a secret. So this is the actual implementation of it. This is interesting. At least the signature to a function that has that can return an error, but it's always the first parameter, so it can likely sit in a register and stay there. That is it for the pet. When no errors occur, it's particularly free in terms of performance. When generate the code for a function that returns an error, just before the return statement, only for the return statements that return errors, Zig generates a call to this function. This is very cool that they explain what happens under the hood. So they call this one with the stack trace pointer, void is the return. Then they access this instruction addresses, the same as here. Stack trace index. Okay, they take the index from the stack trace. Then they have this built-in return address. So they get the address, assign it to that index actually. Then they do. So I mean, for this instruction addresses, they take this index and then they assign whatever this returns, and then they take the index from the stack trace and then assign it. So basically they will change this later to +1. So they increment by 1 because it's the same, right? Stack trace index, stack trace +1, yes. It's modulus n. Okay. Modulus n. Cost is 2 mat operations plus some memory reads and writes. The memory access is constrained and should remain cached for the duration of the error return bubbling. Should remain cached, okay. As for code size, cost one function call before a return statement is no big deal. Even so, I have planned to make the call to Zig return error a tail call, which brings the code size cost down to actually 0. Okay, this is like so performance-wise heavy optimization. They are really forcing it to the limits. What is a return statement in the code without a return tracing can become a jump instruction in the code without a return tracing. So on assembly level, it can just jump. Return statement in the code without error. Return tracing can become a jump instruction in the code with error. Okay, got it. Yeah, so these were very interesting, but also a little bit complicated. So that's why I couldn't even practice. So I didn't want to spend too. I kind of like wanted to go through the wide first and then deep later, so that I kind of have in my mind at least the feeling what can be done and how they, in general, how the error handling could look like in Zig, but definitely I will have to play. So this will probably be a bit harder because they don't provide a lot of examples here. So I will have to, for error handling, I will have to find some examples somewhere else outside of the docs if I don't manage to do it myself. Probably if I do it myself, I'll just do some simpler examples. I will not be able to fully implement all these things. So I'll think how I can actually play more with errors and where to find the resources. Maybe I will check what you said, like Robert, the Zigster, right? So maybe they have some interesting examples about these things, error handling, so that I can practice there, one of the things. And I also wanted to ask, like, you guys, if you have some favorite YouTube channels or other resources where you like these Zigsters, how it's called. It would be cool to see what you guys use. And I was also thinking maybe I will also make something like a special edition of the stream where I will, in parallel with these like regular streams that I have for each day, where I will just like search the YouTube for starters and see what channels are there and what videos are about Zig and how they look like. I mean, I'm not going to watch and spend a lot. I will just like briefly go into the channel, see how many videos they have about Zig, how long are they, what they cover, which are the topics, and so on, to see the state. So I was also avoiding this because, like I said, I wanted to be literally like without any experience before I started this series of streams, so that it's more realistical to so that people can see how I analyze things without literally like with zero knowledge in advance. But now I can just like widen up a little bit because I need to. So we are going into more and more complex things, and it will not be just like enough for me for some of these things to read in the docs. It will not be possible, so I'll have to expand to other resources as well. Okay, so for tomorrow, there aren't really many learning materials online. Yeah, so I guess I'll have to experiment. Yeah, trial and error. So I'm not even sure because I want to say I'm not sure about tomorrow if I'm going to make it in time. Let's say in 1 hour and a half, and maybe even 2 hours will not be enough for me to try and implement error handling in the tic-tac-toe and refactor it. So maybe I will try to implement some basic pointers and convert just for practice. I don't need pointers for tic-tac-toe, but just to practice pointers and these things. Tomorrow I will try to convert it to something that uses pointers. I'll see how. And instead of like these simple variables, I will use pointers and play with them. And I will try to implement as much as I can errors and error handling. And then I will stop. Like I will not, if I spend 2 hours or even less, I will stop there. So if I cannot just like do what I had in mind, I will just stop, and then I'll figure out where to learn the error handling from. And maybe I will also, before tomorrow's refactoring part, maybe, why I say maybe, because I don't know how much time everything will take. I don't want to have like a stream for 5 hours. So maybe it would be also a good idea that tomorrow, before I do this like refactoring the tic-tac-toe, it would be a good idea if I install everything locally. So hopefully that will not take too long, too much time, so that I can play locally as well, and then try to refactor as much as I can in, let's say, 1 hour and a half, maybe a bit more. I don't know how far I will progress. That's why it's kind of like very hard to predict, because I can get stuck very easily somewhere and then waste a lot of time on something, and I don't want to just like waste your time. So definitely tomorrow I will do a regular one, normal, like the day 16. I will see what is next. Let's say optionals. I think optionals are next on the menu, and I don't know how long this will take. So if there is time, maybe also play with casting. But I will also do this, let's say, additional stream where I will do the tic-tac-toe upgrade refactoring, and we can go from there. So definitely tomorrow I will not then do this like research on YouTube or other resources. I'll just do that maybe a few days later after this. I don't know how many days, because if I don't finish everything that I want, if I don't have this tic-tac-toe refactored, that it completely works with pointers, and that I have something that I'm kind of like satisfied how many things I practice, then maybe I will do it also the next day. So I will continue if it gets longer than I expected. If it's within these 2 hours, let's say, like the most, then maybe the day after I will do this research. So it depends on this. I want to finish this first, the tic-tac-toe part, and then research these YouTube channels and other resources. Maybe even use AI, see how it will help. AI is like a double-edged sword, because sometimes it will just, options are fast. Yeah, thank you. But then probably casting as well tomorrow. Yeah, I was saying AI is kind of like double-edged sword, because it can hallucinate, so it can do some weird things, and it can direct me in completely wrong directions. It's kind of like a gamble. So it can be a nice thing. It can, even if it directs me in the wrong direction, it can make me think in a way that will help me understand things. Sometimes that happens, but sometimes it just like it makes me run in circles, and that's why I don't like using AI in this way. But yeah, if I'm out of options, for example, whenever I do something that I cannot find. So for example, a few weeks ago I was doing something like a Solana developing, and I was doing Rust with Solana, and there were simply too many unknowns for me. So they use this, like there is this Anchor, it's called framework that you use on Solana, and because I didn't have experience with this framework before, it was completely hard to work with, and I used AI to help me to go through it, but it was making me run in circles sometimes. But eventually I got some ideas, so it was not like what AI suggested didn't solve the bug that I had, but it eventually made me think in a direction that helped me to solve the problem. So hopefully that will happen if I get stuck here. That will help me. Well, okay. So that's a plan for tomorrow. So basically, I will do tic-tac-toe refactoring. Try to wrap it up, and then the day after, if it's finished, I will do this research into resources for Zig and play with AI. If not, I will then just like continue upgrading the tic-tac-toe, and definitely tomorrow I will do end the day next, like every day so far I will do the regular day 16, day 17, and so on. Okay, thank you guys for being here today, and sorry if like I said before, I was maybe slower today because I haven't slept at all, like 1.5 hours in total. So hopefully I will get some sleep tonight, and tomorrow I will start fresh. Have a nice rest of the Sunday, and see you tomorrow. Bye bye.